this warm-up question, I want you to graph this inequality, is what we call it, on a number line, okay? So we have to kind of think back to what we know about inequalities. So when you graph this, what was the first thing you did here?
Put a -1.
Put a -1 on the number line? And then what? What other numbers need to be on the number line? We at least need the 3, right? Is that going to go to the left of -1 or to the right? To the right, okay? And if we even wanted to include all of the intervals here, we could, okay? Now what? Okay, so we see the x. So when we're graphing inequalities on a number line, we actually have to think back. So we dealt with open and closed circles. So if you can remember, what tells me that I'm going to have an open circle?
When there's no line after the...
When it's not equal to, it's just less than or greater than. Okay, so which number should have open circle? The -1, okay, because this is just a less than symbol, okay? Which number is going to have a closed circle? The 3. Because it's less than or equal to. Okay, and then we've got to figure out where to shade this, okay? So one thing that we have talked about before, and that we should know how to do, is I can actually break up an inequality like this, okay? So when I do that, I've got to make sure I use the whole middle and the left side. That's one equation. And then my second equation is the whole middle and the right side. So x is less than or equal to 3. So those are my 2 equations that I'm graphing simultaneously, okay? One thing we've got to really pay attention to. Do we see here that the x is being eaten? The variable is being eaten? Okay, so that means what? What does that mean?
That x is greater than the -1.
Yes, and you can write it the opposite way, right? If I flip something around, I just got to make sure I flip the sign too. So the x is greater than -1, which means to shade left or right of -1. Right, okay, so we'd be going this way. X is less than or equal to the 3, so that's going to be shading left or right of the 3. Left, so this is actually going to be just all of the shading in the middle of this. Does that make sense? Okay. Any questions on that? All right. So that's a good introduction into today. We're going to be talking about how to solve inequalities, okay? So first thing we want to talk about, it says during this chapter we'll need to know how to state the domains for all equations and all inequalities. Here's the best way to remember it, okay? And we have talked about this when we did our graphing unit, okay? Domains are the x values, right? So it's what x could equal given a type of function. So when we see it on a graph, we talk about domain being from the left to the right. Okay, and if we have asymptotes, we have to make sure we go around those, right? Make sure we go around any holes if we have those. So basically what we mean here is that every single type of function is negative infinity to positive infinity, except for these 3 things, okay? Rational functions are not, right? Because if we think about rationals, what do their graphs look like? Yeah, the opposite quadrant graphs, okay? So those had the asymptotes, right? So those were not negative infinity, positive infinity for domain because we had to work around the asymptotes. But the reason, equation-wise, why we can't do that is because we can't divide by 0. So if we set the denominator equal to 0, whatever number that ends up being, that's going to be an asymptote. It's going to be undefined, okay? So rationals are an exception. Logs are also an exception. Why were logs not negative infinity, positive infinity? What do those look like? Yeah, they had a vertical asymptote, right? And then they shot to the right, okay? So they could start at the asymptote and then go right. So asymptote to infinity. And the reason for that is that logs can't be negative, right? They're undefined. So that's the second exception. And then the third exception to the rule, the square root functions. Can we take the square root of a negative number? No. So that was the last one. Okay, so those are the only three things that are not negative infinity, positive infinity for domain. Everybody with me on that? Blake, you got it?
Yeah.
Claire, you got it? Okay. Basics of graphing inequalities on a number line. So we kind of just talked about this, okay? First symbol that we might see is this thing. What is that? What do we call that? Greater than. And this one? This one? And this one. Perfect. The first two have what type of dot? Open or closed? Open. Yep, if they're not equal to, they're open. And the next two? Closed. Okay. And again, these two rules. If the variable is being eaten, you graph to the right, okay? If the variable is not being eaten, if it's being pointed at, then you're going to graph to the left. That's the difference between greater than and less than, okay? Note, when we're solving solving inequalities, they're just like equations, but when we divide or multiply by a negative number, we must, anybody remember?
Flip the sign.
Yep, flip the sign. Gotta flip the sign. Domain for all inequalities. What do we think that is? Are inequalities ever going to be rationals, logs, or square roots? Nope, not the kind we're dealing with today. So what's the domain going to be? Negative infinity, positive infinity. Cool. Everybody got that? All right. So given the following examples, solve and graph on a number line. Okay. Here is the problem right here. And it wants us to solve and graph this. So when we see a problem that looks like this, we always follow order of operations. Okay. So if I think to order of operations, it's PEMDAS, right? Please excuse my dear Aunt Sally. The P in PEMDAS stands for what? Parentheses. So we got to get rid of those parentheses first. Give me 1 second. We said parentheses first. So the first thing I'm going to do is distribute, okay? So this negative 11/3 is going to both of those values. Here's the thing, okay? I had a lot of different questions the last 2 days when I taught this about, well, I don't like fractions. Can I convert everything to decimal first, okay? That's fine with me if you want to do that. The only problem you're going to run into is that if on the EOC it says to leave your answer as a fraction, you're going to need to know how to convert that decimal back to a fraction, okay? Or if it's multiple choice and all the answers are fractions, you're going to need to know how to convert those fractions into decimals, all right? Can you leave it as fractions for right now? Yes, that's what I'm going to show you how to do, okay? And I'm actually going to show you a little, calculator trick that I thought you guys knew how to do already, but it came to my attention that we did not. So that's what we're going to be talking about here. So the first thing I'm going to do is that negative 11/3 times 7/3, okay? So I'm going to type that in my calculator. So to do that, I'm going to hit negative 11 ABC 3 times 7 ABC 3. And you should, if you have one of my calculators, you should get a mixed number. It should say negative 8 5/9, okay? I don't want that. I don't want a mixed number. That doesn't help me with anything. That just is going to make me do more math, okay? There's a really easy way to get this calculator to tell you what that is as an improper fraction, okay? So if you hit the second button and then you hit that ABC button again and you hit enter, does it give you in a mixed number? Does it give you negative 77/9? Yeah. It should, okay? So that's that little trick. Okay, the other thing I could have done is just done this in my head. Numerator times denominator, negative 77/9. Okay, and I would have got the same thing. But again, using that button, and then if I hit second, I hit ABC again, it's going to switch it back into the mixed number. So if you want to go back and forth, make sure we know how to do that, okay? So now I want you to try it with negative 11/3 times negative 11/3. And tell me what you get. convert it to an improper fraction.
21 over 9.
Yep, 121 over 9. Could have also just done negative 11 times negative 11, 3 times 3. Same thing. Okay, and we don't distribute to the right side because it was not in the parentheses. Okay, next thing to do, okay? If I was following order of operations, I would subtract over that constant, right? And then I would divide by the fraction in the front, and then I'd end up with an answer. That's totally fine. You are welcome to do that, okay? I had some people first hour yesterday, and they preferred to do it that way. They're comfortable with typing fractions into their calculator and getting the right answer. So if that's you, I want you to check yourself today and make sure you do get the right answer, but you're welcome to do that, okay? But let's say that you're not comfortable with fractions, because let's be honest, a lot of us see a fraction and we just kind of freak out, okay? Maybe we just skip the problem in general. A lot of us do that, so please don't be that person. But if you're one of those people, we can do just what we did with rational equations, okay? We can look at all these denominators and we can multiply by a common denominator and get rid of those. So what will 9, 9, and 27 all go into? What will they all go into?
27.
27, yep. 27 won't go into 9, but 9 will go into 27. Okay, so now I'm just going to multiply this 27 times each of those fractions. So I literally just type in my calculator, 27 times negative 77, hit enter, divide by 9, and I get negative 231x. Everybody get that?
Yep.
Okay, now keep going with it. Multiply by the second fraction. Plus 363. Is less than
Oh yeah, 1,200.
Yep, 1,210. So that, to me, looks a lot prettier. Wouldn't you agree? Looks like it's a lot easier to solve, because now I can see my steps and know what to do here. So the first thing I would do is I would subtract the 363. So I get negative 231, x is less than, and then we'll do 1210 minus 363, and we get 847. And last but not least, divide by, and what happens when I divide by negative 231?
You flip the sign.
Flip the sign. Okay, the decimal you get is negative 3.6 repeating, but let's say I want to get a fraction. Okay, I'd do 847, ABC 231, go back and make that a mixed number, and you should get negative, if you do 847 ABC 231, and convert it to an improper fraction, tell me what you get. Anybody? Okay, but make it an improper fraction. Yep, so hit second and then hit ABC.
Is it negative 11 over 3?
Negative 11 over 3.
So
There we
I hit
go.
the second before I do the
Anyone confused on how to do that? Okay.
No.
So, would the
You wanna
Why is being weird?
would the 847 be a fraction or do the
ABC
So we're gonna do 8
So then you get that, and then you wanna go-
negative and then 847 divided by
Okay.
like over like a fraction.
Anybody else?
I can help.
Okay. Last but not least, put this on a number line. Okay? What two numbers is negative 11 thirds going to be between?
Zero or negative 1.
Nope. What is negative 11 thirds?
3.6.
It's negative 3.6. So what two numbers would that be between?
3. Well, negative 3.
Negative 3 and negative 4?
Yeah.
Which one comes first?
Negative.
Yep, negative 4. So we gotta think about our number line here. Okay, so it's gonna be closer to the -3 or the -4. The -4, good, and it's gonna be an open or a closed dot. Open, and we're gonna shade to the, yep, to the right. So if it's greater than, we want all the values bigger, so that's to the right. Okay, questions on that? Okay, practicing. You're gonna do number 2, so I'll give you a couple minutes. Solve it and put it on a number line. Okay, so the first thing we should do is what?
Would you add the 7 over 3? Oh, when you multiply -7 over 3
Mm-hmm.
fractions.
Yep, we're gonna distribute. You got it. So the -7/3 is gonna go to both of those fractions. Cool. So when we do that, do we do anything with the 9 over 2 in yet? No, we'll leave that there. And then -7/3 times -5/2 in
35 over 6.
35 over 6 in, good.
And then 49 over 12.
Yep, I think yours might look like it's negative on here, does it?
Yeah.
Yeah, so we'll just go ahead and leave it as negative. So plus 49 over 12, good.
And it's greater than -257 over 6.
Perfect. Then what?
And then you put parentheses around all of it.
Yeah,
Out of 12.
multiply by 12, good.
And then you just do that.
So it's going everywhere. So 12 times 9/2 in.
54 in.
12 times 35 over 6 in.
70 in.
12 times 49 over 12.
49. And then it's greater than 514.
514.
Just add your ends.
It's -514, right?
Yeah.
Okay.
No. I got positive.
Since it's 12 times -257.
Yeah, it is.
Yeah, it's gonna be negative. Okay. Good. One thing I got asked last hour is before I did this, could I have gone ahead and added these two things, combined like terms first? Absolutely. Okay. But as you can see, it's a little harder to add 9 over 2 plus 35 over 6 than this right here. Okay. That's a little easier in my book, but totally up to you whenever you do that. It does have to be done either way. So when we combine those two numbers, what do we get?
124.
124n plus 49 is greater than -514. Now we must subtract the 49. So 124n is greater than,
-563.
okay? And last but not least, should we flip the sign when we divide by 124? Why not?
Because
It's not a negative.
Oh.
So what is -563 divided by 124? -4.54 if we leave it as a decimal, okay? If we leave it as an improper fraction, I'm not even sure if that simplifies. It might just be -563 over 124, okay? But either way, make sure we know what that is both ways. So then we put it on a number line, and that's going to be between what two numbers? -5 and -4, but a little bit closer to the -5. Open or closed dot? Open and shading to the left or right? To the right. Good. Greater means values greater. That variable is being eaten. I like to think of that as kind of like an alligator, right? Okay. If the variable is being eaten, shade greater. Say what?
I drew teeth on mine,
You draw teeth on yours? That's fine.
like on the nose,
Mhm.
when I put teeth, they were very eating.
It's good. All right. Cool. Special situations. So sometimes when you're dealing with inequalities, your variables disappear, okay? So when this happens, there's no need to freak out, okay? But it's going to be one of two special situations, okay? So if you end up with your variables disappearing and you get a true statement, meaning like I get, for instance, the statement 5 is greater than 4, okay? We know that that's true, so that would be what we call infinite solutions. Okay, let's say we get a false statement though. Let's say we get 4 is greater than 5. We know that's not true. What kind of solution type do you think that's going to be? Something's not true. So, instead of infinite solutions, it would be undefined or no solution, right? And we also use this symbol right here to represent that, okay? So I want you to solve this inequality, and I want you to figure out which type of special situation that's going to be. Don't shout it out. All right, so first thing we got to do on this, if we're following order of operations, is what? Parentheses. Yep, distribute the 7. So we get 7x minus 28. Good. And then we go to subtract over our variables. It doesn't even matter what side you subtract to because you're going to realize pretty quick that the 7x's cancel out. And we're left with 3 is less than negative 28. Is that true or false? False. So that's a no solution. Good job. Okay. Yes.
I did. I took the 3 over. You got like negative 31.
Okay, so you had
0 is less than negative 31.
0 is less than negative 31. Okay, which is still false, right?
Yeah.
Yep. So either way, that works too. For sure. Okay. Any other questions? Caitlin, you have a question? You look confused.
I was confused for a second, but
All he did was he moved the variable over and then he moved one of the numbers to a different side too. Okay. And that works. And same thing if you would have added the 28 over, okay, you would have ended up with 31 is less than 0, which you know is also not true.
I thought
Okay.
it was
What?
I was just saying if I can go wash my arms.
Wash your arms. We're almost done. We don't have too much longer. Okay. Next thing that we're going to learn, compound inequalities. This is when we place two inequalities together by either and or. And or. Okay? If it's an and function, it's typically written as one problem, like our warm-up was. Okay? This is what we call an intersection. So basically when we do our shading, okay, we want what both inequalities have in common. So what they both have in common is what we're looking for here. If one has something that the other one doesn't, it really doesn't matter. Okay, we only are looking at what they both have in common. That's going to be what our solution is. Okay, and then the or function is going to be different than that. That's going to be a union. Okay, so that's basically everything your graph is going to cover. Okay, typically this one, we said the intersection looks kind of like a line segment, like our warm-up did. This is going to look like typically two arrows going in the opposite direction. Okay, when we are graphing these, when graphing an and function, think and starts with an A, so we're graphing it above the line. Okay. Reason for this is we need to figure out where exactly the intersection is, okay? And really prefer that you write in pencil this unit because you're gonna want to go back and erase sometimes. So make sure that you don't write in pen. And then the other type is or. When you think or, you can go ahead and graph that on the line. There's not going to be any erasing because, again, you're going to need everything that both of them have. All right. So, first example of this. This one's written together, which means it's probably going to be a and or an or. And, yep, if it's written together, it's going to be an and. most of the time, all right? So when I look at this, I want to go ahead and break this into two problems since it's written as one. The first problem is going to be from the 8 to the, what do we think? Should I split it in half like this? No. What should the first problem be?
Probably just the 8 to -2, yeah.
It's actually going to be the whole middle.
Oh, isn't it like the 8 in the middle and then 48 in the middle?
So the second problem is going to be the 48 in the middle. Yep. So those are my two problems right there. Okay. That's one of the biggest mistakes. We actually just did this in integrated here recently. Okay. And so what they really wanted to just divide this problem down the middle and make the left side and the right side your two problems. Don't do that. Okay. So the whole middle of it needs to be in both problems. So your first problem here is 8 is less than -2 minus 10x. And the second problem is -2 minus 10x is less than or equal to 48. Everybody with me? If it's an or problem, it's typically written as just first problem or second problem, so they're already divided for you. Okay, but this one's an and function because it's written together. So now we just want to solve this. So the first thing we need to do on the left problem, add the 2. 8 plus 2 is less than the -10x. Then I need to divide by -10. What happens when I divide by -10? -1 is x. Good. And if I wanted to write that with the x on the left, just because that is kind of the preferred way to write it, what would it look like? If the x is going to be on the left, x is less than -1. Yep, we can see that the x is being pointed at here, so if we're going to write it the other way, x also needs to be pointed at. Okay? And then the second problem, solve very similar. We're still going to add the 2 over. We end up with -10x is less than or equal to 50. Divide by the -10 again. Still going to flip my sign, so this is now going to be x is greater than or equal to 50 divided by -10 is -5. Cool. And the x is already on the left on that one, so I don't need to worry about anything. So my two numbers that I most definitely need on this number line are, yep, -1 and -5. And which one comes first? -5, good. It's okay if you just put the -5 and -1 on there, but I'm just going to put the numbers in between as well. On the -5, okay, what type of circle do I need?
Closed. Open.
Yep,
No,
closed. Closed. Okay, and then on the -1, what type of circle do I need? Open. Cool. And then we said this is an and problem, right? So we're going to shade above the line just to see what the shading looks like. So we'll start with the -5. If x is greater than or equal to -5, am I shading left or right? Right. Okay. If x is less than -1, am I shading left or right? Left from that circle. And then again, this is an and function, so I only need what they have in common, right? Which is just going to be this middle part. It's just going to be the middle part. So that's why I said write in pencil. So you can go back and erase. But it should just be the middle part. I'm not the best artist here, so if yours looks a little nicer than mine, that would be good. Any questions on that? All right, you're going to do the next one. So go ahead and try this one. It's obviously an or problem because it has the word or in it. So go ahead and give that a go. First problem, what do I need to do to solve that? Add the 1 over. So 7x is less than, and divide by Do I need to flip it? No, why not? Divided by a positive, yep, so don't flip it. So x is less than -9, cool. Next problem, what do I need to do there? Subtract the 2 over, so I get 7x is greater than or equal to 7.
-7 for the first
Say what?
one. For the first one, it'd be -7. Around it looks like a negative.
Oh, yours looks like a negative?
Yeah, ours looks like, ours looks like a negative.
Can we change it to a plus? Sorry.
Yeah.
These notes are a little bit too light. Okay, so when we do that, we divide by a positive 7 this time, so we don't actually have to flip it. It's just going to be x is greater than or equal to 1. Okay, if you left it as -1, I guess it will still work on this one. All right, so my two numbers I need on this number line are, 1 and -9, okay? We know -9 is going to come first. On the -9, I need a, what type of circle? Open on the 1. Closed, and since this is an OR function, I can go ahead and graph on the line because I know I'm not going to be erasing anything. If x is less than -9, it's going to go to the left. Okay, if x is greater than or equal to 1, go to the right. So typically this is what an OR function should look like, okay? Typically that's what it should look like. One thing too, but you have to make sure you have it set up right. So anytime that you're graphing an inequality that you have solved already, okay, and the x is on the left, so again, x is on the left side. Do you see how this less than, how it's pointing to the left, this arrow? Then this went left. Same thing here, greater than, the arrow's pointing to the right, and this went right. Okay? As long as the x is on the left side, when you set this up, you can do it that way. But the better way to remember is that if x is being pointed at, it's less than. If x is being eaten, it's greater than, no matter what side x is on. Okay? That will work. So any questions on that? Okay. Absolute value inequalities. These are not too bad. Okay? First step, you've got to isolate the absolute value. Get that by itself. The next step, you've got to make a big decision here. Is this going to be an AND function or is it going to be an OR function? How do I know which one is which? Okay, do I get to pick? No. Okay, you've got to pay attention to the sign. So once you've isolated that absolute value on the left, if it's a greater than sign, so greater than or equal to, sorry, it is going to be an OR function. Think greater. If it's a less than sign or less than or equal to, it's going to be an AND function. Think less than. Okay, I know it sounds funny, but just a good way to remember it. Once you've done that, you're splitting these into two problems. Your first split is just going to be drop the bars, keep everything the same. Keep it the same. Don't change anything. The second split, though, you're going to drop the bars again. What do you think is going to happen to the sign? Flip it. And then you're also going to make the right side negative. Make the right side negative. If the right side's already negative, it will become positive. Okay, because a negative number is a positive number. And then, last but not least, solve it. Solve it. That's it. Everybody got that down? Jocelyn, you good?
Yeah, my arm itches.
Okay. We're going to do one of these, and then we're going to do one of the next type, and then we'll call it a day. All right? First things first. Absolute value. We got to get it isolated. Is it isolated right now? Nope. This is not isolated. Are absolute value bars the same thing as parentheses? No. Do not distribute inside of them. Never, never, never. Okay? They're not parentheses. So, if we're trying to get this thing isolated, what do we need to do here? Subtract the 7. I agree with that. So we end up with -8 times absolute value is greater than or equal to negative, what's negative 57 minus 7? Yep, negative 64. And now how are we going to move that 8? Or sorry, the -8. Division, good. To divide it over. Can't distribute it. Nope. You just want to divide it over. So on the left, we end up with
Absolute value 9x and -1.
make it a positive 1. Should be plus 1. So absolute value of 9x plus 1.
Oh, and the change is the flip, the sign change
Why?
because we divided by a negative.
We divided by a negative, good. And negative 64 divided by -8. 8, good. Good, good, good. Everybody with me on that? Okay, we're almost done. Now it's time to split it. So the first problem, drop the bars and keep everything the same. Second problem, we drop the bars. We do what to the sign? Flip it and then make the right side negative. And then we just solve them and we graph them, okay? When we isolated this absolute value, though, what sign is this right here?
Which sign? Oh, the ups.
It's less than or greater than, which one? From right here.
Oh, the greater,
Hmm.
less than.
It's less than or equal to, right? So if we are thinking less than, this is going to be less than. What type of function is this supposed to look like? It should look like an and function when we're done, okay? Should look like an and function, and we know that those are supposed to look like line segments. So we solve this on the first one. How do we solve that? Subtract the 1 over, so 9x is less than or equal to 7 divided by 9, so x is less than or equal to 7/9 or whatever the decimal equivalency of that is. On the second one, how do we solve that? Subtract the 1, so 9x is greater than or equal to -9, divide by 9, so x is greater than or equal to -1. Put those two things on a number line. Which one comes first?
7/9.
No.
Oh, the
-1 comes first because it's negative. What type of circles? And it's and function, so we're graphing above the line, right? So we'll start with the -1, left or right? Right, because it's greater than. And then we do the 7/9, left or right? Left. And what do these have in common? Just the middle. Just the middle. So we don't need the left and the right. Questions on that? Do we want to do another one? No? Okay. You're welcome to do this next one if you want to. But we'll go ahead and keep moving on just because it is a Wednesday. We're going to run out of time. How to graph quadratic inequalities. Okay, so these are not hard at all. Okay? First things first. We want to ignore the inequality and make it an equal sign. Make it an equal sign just so that way this looks like something we already know how to solve. After that, we factor. or we use the quadratic formula if we have to solve it. We then decide what type of circles we're going to have, and we plot those values on a number line. And then we pick a point in each region to see if this is true or false. If it's true, we shade. If it's false, we do not shade. Okay, this sounds like a really complicated process, but I'm going to show you how easy this is. Everybody got this down?
Yeah.
Okay, first thing we gotta do is fix my typo. Okay, so this should not already be an equal sign. We're gonna change this to greater than or equal to. So this should be greater than or equal to. Okay. So, first thing we gotta do, we've got to make that sign an equal sign. Okay? Then we know, since it's a quadratic inequality, we are factoring. We cannot factor it the way it looks right now. What do we need to do? Make it equal 0. So I need to move the 5. Perfect. So I end up with 4x squared minus x minus 5 equals 0. From there, how do I solve something that looks like this? X method, what goes on top? Bottom. Two things that multiply negative 20, add to negative 1. Negative 5 and 4, perfect. That was quick. Can't use the shortcut on this, why? Because there's a 4 in the front. Okay, so my two new middle terms are?
Negative 5x and 4x.
And I keep my first term last term. I'm now group. Grouping. The first two terms have what in common?
X.
And when I pull that out, I get?
4x minus 5.
Okay. Next two terms have what in common?
1.
So it just stays 4x minus 5. My two factors then are?
X plus 1 and 4x minus 5.
X plus 1 and 4x minus 5. Just like what I would always do once I got to this point, I break these apart, set them equal to 0 to find my answers. When I do that, my answers for x are going to be?
Negative 1 and then 4.
So if you set this equal to 0, you would add the 5 over and then divide by 4.
Yeah.
So it'd be 5 fourths.
Yeah, 5 fourths.
Okay. Whew, everybody with me so far?
Yep.
Okay, so far we've learned nothing new, okay, other than to change that to an equal sign from the beginning. Okay, we should already be familiar with the X method and how to do that, okay? So now, I've got these two numbers, right? And I'm going to go ahead and put them on a number line. So which one's going to come first? The negative 1, and then the 5 fourths will go after. Okay? Now I'm going back up to my original problem. What type of circles do you think I'm going to put on these dots? Closed, because it's greater than or equal to. So on these numbers, I'm putting a closed circle. Okay? And then last but not least, I don't know where the shading goes on these. I have no idea. Okay? So how I'm going to find out is I'm going to pick a number in each region of this graph. So if you look, you should see that we have 1, 2, 3 regions. Do we all see that? Okay. So I'm going to take those circles off there. So I need to find a number in each region. Okay? So something that's less than negative 1. What's a number less than negative 1? Perfect. What's a number between negative 1 and 5 fourths? 0 is a good one. And then a number bigger than 5 fourths? Nope. 2. Yep, 1 would still be less than, because 5 fourths is 1.25. Okay, so we've got 3 different numbers, and now here's all we have to do. We go back up to the original problem, and everywhere there's an x, I'm going to plug in that number for each one and see if this makes a true statement. Okay, so I'll do the first one for you. 4 times negative 2 squared minus negative 2 is greater than or equal to 5. So if I go ahead and solve this, I can plug it in my calculator, that's the easiest way. But this becomes 16 plus 2, which is 18. Is 18 greater than or equal to 5? Is that true?
Yeah.
Yeah, so this is actually going to be shaded. That region is shaded. So now I want you to do the same thing, but I want you to plug in 0 and I want you to plug in positive 2 and see if those two regions should be shaded or not. When you plug in 0, what does the left side equal? 0. It should be 0. Is 0 greater than or equal to 5? Nope, that's not true, so don't shade the middle. Don't shade the middle. Now you're plugging in 2.
It's 14.
It equals 14. Is 14 greater than or equal to 5?
Yeah.
Yep. So we should shade that. Make sense? Do we want to do another one like that? No? Okay. This was a lot. This was a lot of different things for one day. I totally get that, okay? But we're running out of time here before this EOC, and we got to know how to do all this stuff, okay? So I really, really, really need you to do your homework on time and have it done by next class, okay? There's not very much of it, so it shouldn't take you super long, but please get that done. Okay,